First, I will be discussing the evolution of moon landings. Apollo 11 was the first spaceflight that got humans to the moon. The American crew, Apollo Lunar Module Eagle, launched from Kennedy Space Center on Merritt Island, Florida, on July 20, 1969. After landing, Commander Neil Armstrong then became the first person to ever step on the moon. 19 minutes later, Lunar Module pilot Buzz Aldrin became the second person to step on the moon. They spent a little over 2 hours outside the spacecraft and collected 47.5 pounds of lunar material to bring back to the U.S. The picture on the left is a photograph of Buzz Aldrin on the moon taken by Neil Armstrong. If you look closely, you can see Armstrong's reflection and Aldrin's visor reflection. The picture on the right is Apollo 11 launching into space on July 20, 1969. Before Apollo 11, from the 1950s to the 1960s, the United States was going through the Cold War. This was a geopolitical rivalry between the US and the Soviet Union. During this time, the Soviet Union launched the Sputnik 1, the first artificial satellite. Because of the success, the United States feared that the Soviet Union was capable of launching nuclear weapons far distances. This created the rivalry between the two that later led to the space race. There was a lot of planning that had to be done before Apollo 11 launched into space, like who was going to take the first steps on the moon. When Buzz Aldrin was told that Armstrong would be the first to walk on the moon, he was furious. He later accepted the fact and was told that Armstrong was chosen because he was the commander. When deciding where the landing site on the moon would be, there was a lot of factors that had to be met. The space needed to be mostly smooth, with almost no craters. There needed to be good visibility and no temperature extremes. Now, let's look 3 years into the future. Apollo 17 was the last moon landing in NASA's Apollo program. It launched on December 7, 1972, from the Kennedy Space Center in Florida, the same location as Apollo 11. The crew consisted of the commander, Eugene A. Cernan, the command module pilot, Ronald E. Evans, and the lunar module pilot, Harrison H. Schmitt. A biological cosmic ray experiment took place on Apollo 17. The experiment entailed implanting radiation monitors in 5 mice to see if they suffered damage from cosmic rays. This experiment only found lesions on the scalp and liver of the mice, but there was no damage to the brain.
Between the two rivals, the United States and the Soviet Union, there was a hot competition happened in the 1980s. The two countries desired their space strength to a grouping of national security and foreign policy aims, also for political and military advantage. The race initially appeared like an alliance, but the craving for weighty space collaboration grew stronger and debilitated their union as both nations hunted strategic cooperations in space. The genesis of the space age resulted from the unveiling of Sputnik by the Soviets. The United States government made NASA a national initiative. Soviet leader Nikita Khrushchev claimed technological power of communism in 1957. His country was the first to unveil a satellite and insisted on it after another flight was realized in 1961. The US leader, John F. Kennedy, decided to reveal a program with intense results, referring people to the moon to attain technological control over the Soviet Union. This power and prestige would be the trigger of the battle, along with the fluid observe of the Cold War. The race lasted until the failure of the Soviet Union in 1991, but it considerably impacted the pace and content of their space programs.
Over the years of space exploration, scientists have conducted about 4 main types of space missions: flyby, orbiter spacecraft, rover, and human space explorations. Scientists and astronomers used a telescope to observe space before we had the technology to send objects into space. It was first invented in 1608. The telescope allowed for the first telescopic observation of the night sky, the discovery of Jupiter's moons, and the first clear telescopic photograph of the moon. As technology advanced, we had the ability to create flyby spacecrafts. These spacecrafts are essentially the first phase of space exploration, in which they follow the continuous solar orbit and pass by celestial objects. As it passes by, it has the capacity to use its instruments to observe targets and send information that it collects back to Earth. An example of the flyby spacecraft is the twin Voyager 1 and Voyager 2 spacecrafts that conducted encounters in the systems of Jupiter, Saturn, Uranus, and Neptune. Orbiter spacecrafts are considered the second phase of space exploration. It is a type of spacecraft that is designed to enter the orbit of a planet. While orbiters can't land on the surface of a planet, similar to flybys, it can collect significant data and information about the planet. An example of an orbiter spacecraft is Galileo, which in 1995 entered Jupiter's orbit. Rover spacecrafts are electrically powered spacecraft rovers that can roam on celestial objects, take pictures, collect soil samples, and more tasks. This form of space exploration is unique because of the tasks it can perform on the surface of a celestial object that provide extremely detailed information to scientists and astronomers. An example of a rover spacecraft is the Sojourner rover. Lastly, we have human space explorations, which first successfully occurred in 1961 by the Soviet Union. This type of exploration is a space flight with a crew of astronauts on a spacecraft that have the ability to operate the spacecraft as well as being operated remotely from Earth. A spaceflight is the use of space technology to achieve the flight of a spacecraft into and throughout outer space. Space flights and satellites are used for space exploration and have opened up the possibility of the commercialization of space through satellite navigation systems, satellite television, and in the future, possibly space tourism.
Talking about the future of space exploration. One of the major players of future space exploration is currently SpaceX, and particularly with their mission to Mars. They have a plan for their first mission to Mars in about 4 years, so 2024, and there's talks of a lunar mission in 2022, so in 2 years, with the idea of building up to Mars, which would be obviously a more difficult mission than a mission to the moon, since Mars is farther away. Elon Musk has spoken about the possibility of a Mars base as a goal. There's no plans for it yet, but Elon Musk thinks that Mars would be a good place to try to make a colony off of Earth, and thinks that Mars would be a good place since Mars is similar to Earth in terms of it has similar size and geographic, so that would make it easy to make a habitable place for humans. The spacecraft that SpaceX is working on at the moment is called Starship, and it's revolutionary in that it's a fully reusable rocket, and most past and present rockets, they're all one-offs in terms of when it's used for its mission, it can't be used again. But Starship would be able to be used for several missions over and over again. And it's very versatile in that it could be used for Mars missions, lunar missions, other places in the galaxy, in theory, wherever they want to send it. And there's even talks of it could be used Earth-to-Earth trips, such as like going from the United States to Europe. And it can carry in excess of 100 metric tons to Earth's orbit, which is good because it's expensive to transport heavy objects and goods into space, such as water is very expensive since it's dense, and to carry a large mass of water would be difficult, but the Starship can carry a lot of weight, so it would be more cost efficient if they decide to export water. There's also, at SpaceX, they're working on developing a delivery system for satellites using Starship, which would make a lower cost delivery system for satellites, since Starship is so versatile and can be reused. The Starship engine is called Raptor, and it's reusable. A reusable Methalox staged combustion engine, and it began flight testing on a Starship prototype in July of 2019, so it's been testing for about a year now. And it's revolutionary, and it's the first full flow staged combustion rocket engine ever flown. And so it's the first, can be thought of as the first next gen rocket engine. And SpaceX is not the only company that's looking towards future space missions. NASA also has future space missions planned, such as Psyche, which is a mission to send a probe to an asteroid that's between Jupiter and Mars, that's orbiting the sun, that has unique metals on it. NASA wants to get some samples of the metals to test and analyze. They also have an Iris V2 that they're working on, which is a CubeSat, which is developed for a low-cost deep space communication.